All right, Math 1 students, here's our last unit test of the year. Remember that this should be used as a check against your own work or as a way to get some hints to get you unstuck. Because the only way for you to practice for the test and do well in the test is to actually see how much you know and where the gaps in your understanding are, not just to watch this. So if you haven't finished this and you're watching this, pause it right now. Work through, use your note sheet, the reference guide that handed out. This is something you can use on your test. So you should have this out and be referencing it, so you get used to finding what you need on here, and then do whatever you can on here. Then you can check it against the work here. Okay, number 1 says form a linear pair. So what I'm really testing is, do you understand this term? So the sum of their measures is 180 degrees. A linear pair are supplementary. Here's a diagram of what a linear pair would look like. That angle and that angle. ABC form a linear pair and have equal measures. Is ABC acute, right, or obtuse? So I walked you through a proof that had this in it. If you think about, they have to equal 100. So if we say, we have two angles, X and Y, and I would say that they have equal measures. That means X equals Y and X plus Y equals 180. You can see that if X plus Y equals 180, then X plus X equals 180. Or 2x equals 180. So this is the algebraic way of showing that, in fact, x would have to be 90. So the only way to have angles that add up to 180 and be the same is if they're both the same 90-degree angle. So we would say they're right. BAC and DAC are complementary. That means adds up to 90 degrees. So let's see, that means that BAC and DAC are complementary. That means this angle is a 90-degree angle. BE and CF are lines. So what I'm saying is that they look like straight lines. They are indeed straight lines. So the measure of angle BAC. Well, we can't use the complementary, but we can see that since these are straight lines, this is a vertical angle. So this is 63 degrees. CAD or DAC, they're the same thing. Since they're complementary, that means this is 90 minus 63, or 27. Then it says, what's BAF? BAF would be this one, and you can see they form a linear pair. So this is going to be 180 degrees minus the 63 degrees that this angle is. You could also use this 180 degrees. You see how you can either form a linear pair like that, or like that. Either way. So this is 180 minus 60 degrees. So that's going to 63 degrees. That's going to be 117, if I'm correct. Yes, 117 degrees. So it really is just a matter in this one of using vertical angles, knowing what complementary means, and then a linear pair. So you have to sort of work your way around based on what you know. Always a good thing when you're dealing with proofs or geometry is to go through and just check off. Do they have vertical angles? Is there a linear pair? Those are things that all you need is two crisscrossing lines. You don't need to worry about if anything's parallel. Okay, find x. So here we're not proving anything. We're just demonstrating the relationship. If this is 92, this is 92. Now we have corresponding angles. So 2x minus 4 equals 92. Add 4 to both sides. 2x equals 96. X equals 48. So this is dividing both sides by 2. Janelle set up the following equation to solve for x. Should be solve for y, because it's y. So she set this up. 10y plus 10 equals 50. So I have to be able to recognize that what she did is she set up this angle is equal to that angle. Those are not equal, though, because we have parallel lines. So these would be same side interior, which are not congruent They're supplementary. So we would say the one problem that Janelle made was that she set them equal to each other when they are supplementary. Is it possible to prove lines P and Q are parallel? So check the box whether it's possible or not, and what postulate or theorem you'd use. So it is, let's look here. 58 and 122. These are same side interior. So we can prove that they are parallel, and same side interior angles are supplementary. Okay, so here I've got 80 and 42, 82 and 40. 82 plus 40 is 122. So we can prove that they are not parallel because corresponding angles are congruent if and only if lines are parallel. And I wrote this if and only if just to remind you that that is sort of the reason about parallel lines and the angle postulates or theorems around it that are really helpful when we're doing proofs or when we're analyzing a diagram, is that they're biconditional. They go both ways. So that means if they're parallel, then they're going to be equal. If they're equal, then they're going to be parallel, which means that if they're not equal, then they will not be parallel. Not all theorems are like that. Right? There's some theorems which you can't draw that conclusion. But for parallel lines, they're biconditional. So either both things are true, the angles, corresponding angles being equal, or the parallel lines being parallel. Those are either both true or both false. Has to be one or the other. Which of the 5 congruence postulates are not shown here? So that means you've got to evaluate each of these and see which is your congruence postulate. So we have to apply several principles here. This is going to be the reflexive property is going to say we have a side in common. So I've got angle, angle, side. Here I've got another reflexive property. Whoops, I should just mark 1 here. 1. So this is going to be side, side, side. I've got vertical angles here, so I've got side, angle, side. And I've got vertical angles here, so I have angle, side, angle. Now this one, it does have right triangles, so you'd be tempted to say, oh, maybe it's hypotenuse leg, but that's not what proves they're congruent. We only have the leg, we don't have any information on the hypotenuse. So we would have to know something about the hypotenuse leg. So HL, or hypotenuse leg, is the one that's not shown. Here's page 2. Use the diagram below. Choices A to E for problems 12 to 17. Oh, typos again. Problems 8 to 13. Okay, so 12 and 9 form a linear pair because they're along one line. 5 and 13 are corresponding angles. I keep going back to here, but I need to go here. 4 and 10. So those you can see are inside the lines and opposite or alternate sides of the transversal. So these would be alternate interior angles. Notice the diagram doesn't necessarily show us that any lines are parallel, but we don't go off what the diagram looks like. We go off of what we can prove. So we can still identify these as alternate interior angles. We would just, in a proof, we would have to know that they are congruent in order to say that the lines are parallel. But here we're just asked to sort of identify what category of angles do these fit in so that we could check it. All right, 11 to 16, 11 and 16. So those are on the same side of the transversal and inside. So these are going to be same side interior angles, A. 15 and 14, those are another linear pair. And 2 and 6 are corresponding angles. To make sure you're familiar with all of these, I didn't in this one ask you about any vertical angles you can see, but that doesn't mean I won't on the test. So you need to be familiar and be able to identify all of these. Complete the two-column proof by filling in the correct corresponding letters. So the first thing I'm going to have you do is just see if you can complete the proof that's already there, and then I have one here that gives you a proof to do entirely by yourself. So I want to see how independently you can do these proofs. Okay, given J is parallel to K. Remember, we always start out with given, so this would be C, given. Measure of angle 2 plus measure of angle 3 is 180 degrees. So this is the linear pair postulate. Number 3, step 3, it's saying the reasons corresponding angles are congruent. So I look at my diagram and say, well, 1 and 3 are the only corresponding angles that are named. Any other corresponding angles don't have a number on them. So I would have to actually write that into the diagram to use it, and since all we're doing is choosing, I don't need to do that. So I'm just looking for 1 and 3. 1 is congruent to 3. That's in fact true. And then 4. So now we got to finish this out. Well, we're proving, remember, that 1 and 2, adding 1 and 2 are equal to 180. So that's going to be D. That's what we prove. And then the question is, how do we prove that? Well, just going down the list, we've already used this. 1 and 2 are not linear pairs. It's not given. We've already used this. They're not vertical angles here. And CPCTC, that is a reference to triangles. We haven't done anything with triangles. You can't use this unless you've proven triangles are congruent. So that leaves us this, substitution. And substitution is what happens when we say, look, 1 and 2 add together to get 180, and 1 and 3 are on the same team. So I can say 2 and 1. I can put angle 1 in for here. So this is why substitution is the reason. Okay. All right. Finally, our two-column proof. We always start off with given. It doesn't necessarily mean that there's one of the givens that we have to start with, but I'm going to start with the first one I'm given. QP is parallel to NM. After I do a parallel line as a statement, probably the next thing is going to be, showing that something is some set of angles is either congruent or supplementary. So if I know that these QP and NM are parallel, I'm going to mark my diagram so I know what I've proven. Okay. Now, the next thing might be hard to say, like, well, which angle pair relationship am I gonna choose? And in this case, actually, you could choose either one. But you can see that with these parallel lines, we have this line that transverses them. There's a transversal, and there's a transversal. We can choose either one of them, the way this works out. Ultimately, you can see I've got two triangles, so I'm probably moving towards proving that the triangles are congruent. And what I'm trying to do at the end is prove that QP is congruent to MN, so in fact that these are the same length. So I've got triangles, but I'm proving something that's about one side, so probably I'm using CPCTC. Corresponding parts of congruent triangles are congruent. So that's kind of where I'm headed. I sort of think strategically. So how am I going to prove the triangles are congruent? Well, angles matter. They help us prove triangle congruence. So I'll just use these angles right here. The angle PQO is congruent to angle NNMO. You could call it PQM and NMQ as well. But we know these are congruent because those are alternate interior angles. Okay, there's nothing more for me to do here because I don't have any other related angles for that. So now I'm going to go back and go, I've done something with this given. Let's go to the next one. O is midpoint of QM. So if it's the midpoint of QM, this is given. There's nothing to mark there. I mean, I could mark the point there. But remember, anytime we see midpoint or anytime we see bisect, what that does is it creates two congruent halves. So that means half of the thing that has a midpoint is equal to the other half. So QM, that means that this is congruent to that. I'm going to say QO is congruent to OM. And this is the definition of midpoint. So we've got QO and OM. So I've got an angle, I've got a side. All I need is another angle. There are two ways we could do this. I could either look here and say vertical angles, or I could say, well, here's another transversal. I have alternate interior angles. I'm going to do vertical angles, but either one would work. So angle QOP is congruent to angle NOM, vertical angles. Now, because I chose that one, I have angle, side, angle. If you had done the other ones, if you had done alternate interior angles again, that would be angle, angle, side. So what we've just done is we've had an angle, a side, and an angle, congruent to an angle, a side, and an angle. That means I've got triangles. Triangle QPO. QPO is congruent to, now I have to make sure my points line up. So Q and M are corresponding, so triangle M. And then P goes this way, so N is going to be this way, MNO. As long as you have Q, M, P, and N, and O matching up to the same place, you're fine. So they can be in any order as long as each triangle is consistent. So the reason for this, remember, is angle, side, angle. I know some of you are quick to jump to CP/CTC, but that is not a reason triangles are congruent. That's what you can do after you prove their triangles congruent, which is our last step. QP is congruent to NM. And the reason is now we've proven that these triangles are congruent. That means every single part. Sorry about that. It means every single part is congruent to every single part. CPCTC, corresponding parts of congruent triangles are congruent. Okay. Last bit. So here I just have you complete a couple of steps. I'm just checking to see, and on your test, there's going to be a combination of questions that asks, can you go through an entire proof, and can you check some of the important tools in your proofs toolbox? Can you do those? So here we're saying AB bisects CD. Again, that means two halves, right? So that means AX is congruent to BX, or CX, not just or, and CX is congruent to DX. That is the definition of bisect. Here I'm just having you walk through what we do for what we do with proving triangles congruent and CP/CTC. So VXW is congruent to YXZ. Those are vertical angles. Triangle VWX BWX is congruent to triangle YZX. The reason is angle, angle, side. The angle, angle, side postulate. And WX is congruent to Y. Oh my goodness. That's a bad typo. It's not YZ. It's congruent to ZX. So I'll make sure in class I correct that for you. But the reason this is CPCTC. Always proofread before you try and present it, folks. So yeah, once I've proven the triangle is congruent, then each part is congruent. Okay, there is your practice test. If you got stuck on any of those, I encourage you to get a clean copy and work it through from start to finish independently. That's the best way for you to prepare for your test. And this is our last unit test, so it's important that you study for it. And I know if you do and have put in the work with all the homework that you'll do well on it.